This is the FDA's food pyramid. For decades, the predominant thought was that if you follow it, you would be quote-unquote healthy. But does that pyramid really apply to everyone?
Nutrition is not a one-size-fits-all approach. Neither is weight loss, neither is prevention of chronic conditions. And that's because we are all so different.
Eating is one of the most complex social behaviors that we have. We have to do it. We love to do it. It's in our genes to want to eat.
What we eat is extremely important for our wellness, for our well-being, for our longevity, and not just ours, but those of our families too. And so we want to make sure that the food choices that we make every day support health rather than put us on a path to disease.
There are hundreds of diets to choose from Atkins to keto to paleo. But the burgeoning field of nutrigenomics and personalized nutrition throws the idea of a diet working for anyone out the window.
Scientifically, there is really nothing more intimate than our connection with food and how it can affect our genes. The idea of personalized nutrition is that we can discover what diet works best for our genes.
I often tell my patients that your genes are not your destiny, but they are your predisposition. Now we're delving a little further and looking at our actual genetics. What were we born with? What are the genes we were born with? What are the genes we want to turn off? What are the ones we want to turn on? How do we become a place where we know our kids are going to grow up and have an easier time knowing how to structure their lifestyle prescription to match longevity? Nutrigenomics really looks at us as the individual.
At the heart of nutrigenomics and precision nutrition is understanding the human genome.
Genetically speaking, we are very similar, but if we look at those little outliers outside of where we are similar, we have so many things that make us different.
Depending on which variants we carry of these genes, what flavors of the genes we carry, they might affect the way our brain, our body, our cells interact with different nutrients.
And those nutrients we consume can switch certain genes on or off.
So we have about 25,000 genes, but in our brain cells, a set of genes are on and a set of genes are off.
The genome and looking at our DNA is really kind of what puts us aside from someone else and says, gosh, I'm more at risk for this, or I would do better lifting weights than I would running a marathon. So that's where our DNA plays a role.
So the genetic switches are very similar to the switches of light in your room that can control how much light you have, whether it's on or off, or whether it's dial up or down. Nutrients essentially help the molecular machinery that can make these genetic switches easier or harder to turn on or off.
And is there a possibility, say, of giving people foods that are going to affect those favorably?
One of the most striking examples of how food can drive biological processes by interacting with the genome can be found, of all places, in a beehive.
When we usually think of food, we think mostly about its calories and nutrient content. But there is this whole other side of food that is much more intimately connected with our biology. And that is the ability of nutrients to essentially inform and shape our genome, the blueprint that drives all life. There are two kinds of bees, queen bees and worker bees. Queen bees give rise to the entire colony. Queen bees are fertile, they give rise to every other bee in the colony, and they live for years. On the other hand, worker bees are sterile, they don't have any offspring, and they only live for a few weeks. What you might not know is that actually worker bees and the queen bee are genetically identical organisms. What shapes them into these two completely different life forms is actually the food they eat. The queen bee, when she's a larva, she feeds on this food called royal jelly. On the other hand, the worker bees mostly eat pollen, and this food that they get when they're developing determines their physiology and their anatomy for the rest of their lives.